Hi students, this is Mrs. Keller, and I wanted to make a quick video about the unit circle to help clarify some questions that many of you have been having. So I've pulled up here an example of a unit circle that's been all completely filled in. And so you'll notice here the angles in degrees are all labeled all the way around the unit circle, as well as the radians. So if you remember from before all of this started, we started talking about angles in standard position have their initial side along the positive x-axis here. There we go. It's hard to draw with a mouse. And positive angles will rotate around the unit circle in a counterclockwise manner, and negative angles go clockwise around the unit circle. So from here, if this is our initial side and we go 30 degrees this way, this would be our terminal side on the unit circle. And the cool thing, one of the cool things about the unit circle is that we can find the cosine and the sine of any angle just by looking at the coordinates of the point where it intersects. This terminal side where it intersects our unit circle tells us the cosine and the sine of that angle. So I'm going to try to explain that to you right now. If I were to draw a line straight down to the x-axis, okay, making this a perfect right triangle, this is now a 30, 60, 90 triangle, and we can use our side length ratios that we know to help us find the lengths of the sides. By definition, a unit circle means that the radius of the circle is exactly 1 unit. So to any point on the circle from the center is exactly 1 unit. So that means that if this side is 1, then this side has to be, the short side here, has to be 1/2. And then this side here is 1/2 times the square root of 3, which would be the same thing as the square root of 3 over 2. Bear with my drawing. There we go. So here's our 3 sides of this triangle that we've drawn. Grab another color. So the coordinates of this point right here, in the x direction, we've gone the square root of 3 over 2. And in the y direction, we've gone up 1/2. So this point is at square root of 3 over 2, 1/2. Now you might be thinking, well, why do I care about that? Well, if you think back to SOHCAHTOA, right? C-A-H. All right. If you think back to SOHCAHTOA, the sine of this angle right here, this 30-degree angle, is equivalent to the opposite side over the hypotenuse. Well, in this case, the hypotenuse is 1. And for any triangle that we draw in this unit circle, the hypotenuse is going to be 1, which gives us a really cool feature. That means that the sine of this angle is equivalent to the y value, how far we went up or down away from this axis right here. And so this 1/2 is the sine of 30 degrees. The cosine is adjacent over hypotenuse. So if we look here, our adjacent side was the square root of 3 over 2 over 1. So the x value here gives us the cosine of this 30-degree angle. To find the sine and cosine of any angle on the unit circle, once you have all these coordinates filled in, you can simply look. It is always going to be cosine, comma, sine. So the cosine is always the x coordinate and the sine is always the y coordinate. So just to recap quickly, if we wanted to find, for example, the cosine and sine of 120 degrees. Just going to grab another color. So 120 degrees is right here. And so if I look at this point and the coordinates of this point, the cosine of 120 degrees is negative 1/2. And the sine of 120 degrees is the square root of 3 over 2. I hope this was helpful.